Hi, my name is Daniel Brown. I want to give you an introduction to a unique tool, which is part of the upcoming textbook, An Introduction to Derivative Securities. This tool is useful in teaching chapters 12, 13, and 15. We're going to focus on chapter 13 today. Chapter 13 is on option Greeks. So this spreadsheet allows us, and I'll do some other demos of the spreadsheet to give you more information about how it works, but this spreadsheet allows us to put together portfolios including options and look at their risks and also hedge their risks. So I'm going to put an option position in. Let's go short 10,000 call options. We'll go short at the fair value. We book the option. Okay, so this is a picture of the present value of this position for different levels of the asset price, 50 up to 150. And again, this is just using the Black-Scholes-Merton formula to do this calculation. Now, this balance sheet shows us present value of our position, the delta, the gamma, what I call the unit gamma, which again, given spot's 100, it's also 100. The unit gamma is what's the change in delta for a 1% change in the asset price. Vega, rho, theta, cash balance. Okay, let's hedge the delta. I guess first, let's see what the delta looks like. So chart tools, change to delta. We can see this graph of delta. Spot goes down a lot, the delta heads to 0. Spot goes up a lot, delta heads to minus 10,000. We're short 10,000 call options. All of that makes sense. Let's hedge the delta. So we hedge the delta. We're short 6,368 shares. We go long. We can round to the nearest share if we want, but let's just go long. Sets our delta to 0. We can see in our chart the graph is just shifted up. If we go back to our chart tools, look at our value, we see a classic frown. Market goes up, we lose money. Market goes down, we lose money. That's what a delta hedged short option position does. Again, we can validate. Market goes up, we lose a little money. Go back to 100. Market goes down, we lose a little money. But also we see here, as the market moves, 101, we lose a little money, delta changes, right? And of course, we know that. We draw a graph, we can see that delta changes. And in fact, as the market goes up, the delta becomes negative, we're losing money. Market goes down, delta becomes positive, we're losing money. What are we supposed to do as a dealer in options, as a delta hedging trader in options? We're supposed to rebalance our delta. So let's rebalance the delta, we trade some assets. Again, we're short delta, so we buy some assets. We book the asset, and basically we've locked in this loss. Market goes back down, market goes up, we've locked in that loss. Market goes back down, for example, again, the delta changes. We've got a trade, we're long delta, we've got to sell, book the asset, now we've lost $184. Market moves around, and we've lost that money. Can never make it back. Well, not quite. Okay, we can simulate delta hedging. We can think about the value as the market moves. We can think about the delta. Why does the delta change? The delta changes because of gamma. We're short gamma. It's classic short gamma position. Okay, I'm going to clear it out. Let's go back to the beginning. Let's go short some options. Here we are. Here's my position. Let's delta hedge. There's my new position. Now, one of the things, and I always say to the students, look, you're not allowed to be short $500,000 in cash, right? Let's trade a zero coupon bond to maturity to clear out that cash balance. This is set up correctly. Clears out the cash balance. Lo and behold, what do we have? Zero delta, zero rho. Now we can talk about relationships between gamma and theta and what's going on. All right, we've got a present value of 0. How much money do we expect to make or lose from delta hedging? The opposite of the theta. So During the course of the day, and this is kind of the trader thought, during the course of the day on this position, I expect to lose about $102 from my delta hedging, right? The market moves around, we rebalance the delta. Every time the market moves, we lock in a little loss. How much do we expect to lose? About $102.81. Go to bed, wake up the next morning, make the theta, we're back at zero. And so I use this tool to talk about delta and gamma. I haven't talked about it here, but vega and rho and theta and cash. I can talk about all these things without getting bogged down in the detail of the calculations, right? We can change things, we can change assumptions and so on, and the student can start to get a feel for how this works in practice, what delta hedging means in practice, what the gamma means, and so on. We can do options which are very short dated with a really big spike in the gamma. We can look at the vega. We can look at hedging these things and so on. We can look at portfolios of options. And so that's what this tool's for. In chapter 13, I use this tool to talk about the Greeks. In chapter 12, I use this tool to talk about the Black-Scholes-Merton framework. In chapter 15, I use this tool to talk about value at risk. We've got a value at risk simulation, a value at risk tool, runs Monte Carlo simulations. I've got a P&L simulator for if I have this position, what can happen to it. There are all sorts of tools built into the spreadsheet, but one of the key ones here is what do the risks look like? What are the Greeks? How do they fit together? And so on. And I find when teaching about the Greeks, being able to spend the time visualizing the Greeks as opposed to spending the time trying to do these calculations really helps the students learn what we're talking about.